Hi, so I'm Nick Diakopoulos. I'm a researcher at the Tau Center for Digital Journalism at Columbia University. And recently I've been thinking a lot about computational journalism and investigative and accountability reporting of algorithms. So it was 14 years ago that Lawrence Lessig taught us that code is law, that the architecture of the system, the code and the algorithms running it can be a powerful force on our liberty. So let me give you an example of algorithmic power. The New York Times recently reported on a number of sites online that are collecting, organizing, and SEOing mugshot photos. Now, it would be a little embarrassing to have your mugshot online, but these sites are actually exploiting this by getting people to pay money to have their mugshot taken down. So as a society, we can deal with this by passing new laws to prevent it, or we can use market forces like credit card companies denying them, or we can use algorithmic power, which is, it turns out, what Google ended up doing when they downweighted these sites in their rankings. So we're living in a world now where algorithms are adjudicating more and more decisions in our lives, everything from online media to finance, educational scoring systems, predictive policing, social service management, and so on. Investigative journalism has traditionally dealt with trying to uncover hidden information from powerful institutions. It turns out that algorithms are really good at obfuscating and hiding information, so there's a nice connection here back to investigative journalism. What we really lack as a public, I think, is clarity on how algorithms exert power. And they're sort of hidden behind these opaque black boxes. There's a lot of complexity, and we kind of need to get inside that box to understand what's going on. So I think there's at least a few mechanisms how algorithms exert power. They prioritize things, they classify, they associate, they filter, and these can all serve to nudge our attention in different ways or to create errors or false positives and false negatives and so on that might be consequential. So we need to crack into this black box and understand its power. There could be all kinds of dangerous stuff going on in there, sharp objects, or maybe not, maybe just tasty little hot dogs. We could go for transparency, but then we run into issues of trade secret where corporations don't want to be transparent with their code. Competitive advantage, and if you're too transparent, then people start gaming your system. These are legitimate concerns that we have to deal with. Transparency also has the issue of just a high cognitive overhead. So I don't know who here wants to read through 500 million lines of healthcare.gov code, but not me. But there might be an opportunity here to think about different ways to do usable transparency of algorithms. That's a topic for future work. Another way to think about this is something I'm calling algorithmic accountability reporting. It's kind of the idea of reverse engineering the algorithm by looking at the input-output relationship of the algorithm. So, of course, algorithms are black boxes, but they do have two little openings, one on either end, one for the inputs and one for the outputs. And if you shoot enough inputs in and look at enough outputs, you can start correlating those things and developing a theory or at least a story of what's going on in that algorithm. So the Wall Street Journal has actually started doing some reverse engineering projects. They looked at e-commerce sites and staples.com in particular, and were reverse engineering how geography and browser sessions were impacting individual and dynamic prices on the site. And what they found is that the biggest correlation to price was the distance to a competitor's store. So higher prices, surprise, surprise, correlated with less competition. That also correlated with rural areas and poorer areas. I also did a project looking at reverse engineering auto-completion algorithms, Google and Bing. In particular, I was curious about the editorial criteria of pornography censorship and child pornography censorship. So there's some interesting comparisons here to make between these two sites. If you add child to one of the pornography terms that I was sort of reverse engineering, you do actually get suggestions, or you did at the time, that lead to child pornography. So it's a little disturbing. But I think there's some interesting opportunity here to also do accountability reporting. So what kinds of stories do we get from algorithms? We can look for discrimination. We can look for mistakes that might deny something unjustly. We can look for censorship, algorithms breaking laws or social norms like defamation or false predictions. So here are some of the areas where I found algorithms being used in business and government. I think there's gold out there if you're willing to dig for it. Maybe this could even be a new beat for computational journalists. And that's it for me. This is work in progress, and I'm happy to talk to folks.